So quick look at the drawing here, boys. The blower motor is not functioning in my Vitara. I don't have any speed at all, including the maximum speed. There's a wee bit of backstory to this. I'll keep it in my pocket for now, but I have a pretty good idea what's going on and why it's buggerized. As I said, more on that in a wee bit. But here's just a quick review of the circuit here, boys. It's a wee bit of a different design. It is not pulse width modulated as some variable speed blowers are these days. But it is differentially voltage controlled via the blower module here. As you can see, it is not a standard resistor block. There is some active circuitry in here, and basically it takes the speed request voltage that comes from the a climate control module, the HVAC module, and actually sends that request to the blower module itself, the active circuitry inside here. The driver circuit actually puts a differential across, which would typically be just the ground, of course. This is the 12 volt supply on the high side. This is just a relay which is strangely just controlled via the ignition switch, with the ignition switch off, just off the drawing. With the ignition switch on, I should say, it powers the coil, pulls in the contact, of course, and applies the 12 volt to the high side of the motor. And as I said, the speed is differentially controlled via the blower motor controller, item 21, as a function of the voltage which is applied, which is a function of the switch position, or if you're in the auto position, obviously a function of the algorithm of the climate control module itself. Yeah, so you can have a manual speed request or an automatic control request from the climate control module, and it's all acted upon via this blower module. So what's wrong with the system? Could potentially be anything, but as I said, I strongly suspect we're looking at this blower module, and I have a logic to why. Embarrassingly, I'll explain that to you at the end of the video. So let me just confirm the issue with you boys here. So here's the fan speed selector. As you can see, the ignition is on. You can see we have a ramp up on the display, so clearly the control is functional, but none, right? The fan is not running at all. So you guys I've showed you guys this in the past. If you turn the ignition switch on, promptly push the auto and the defrost at the same time, you'll go into the the built-in test facility, and you can see here it's actually displaying code 4.1. okay, code 4.1. Now keep in mind, first step in the actual doing the test is apply the light to the sun load sensor up on the dash there. Otherwise you can get a spurious sun load sensor fault code, and I suspect that's what we've just done. 4.1 sun load sensor, exactly. So there is no fault code except the sun load sensor, which of course is a spurious fault code. So we have no blower control, and yet the built-in test is telling us there's nothing wrong with the system. How come? There is no test facility within the self-diagnostic with respect to the blower speed operation, right? I've showed you guys this before, so I'm not going to dwell on it, but suffice it to say, the system can't recognize that there's a failure, and yet there is. Okay, so what we'll do is we'll check the obvious here, boys. We'll check for a 12 volt supply at the blower, and of course, as I said here, the module actually controls the blower speed differentially. So if we have at the lowest speed, there will be 12 volts and very close to 12 volts, and at the highest speed there'll be 12 volts and of course very close to ground. I think that makes some sense. This is the control line, as I mentioned. The blower module itself is grounded, and tapping off between the line here is the feedback signal to the HVAC module, so it knows that the control is actually is going on. So we'll check the 12 volts, we'll check the control voltage, and we'll check to see the differential voltage which should be applied here, that I suspect is not there. So I think we're going to have the 12, I think we're going to have the control, but I don't think we have the differential voltage output from the module. That is just a suspicion. Don't get sucked into confirmation bias. Keep yourself open-minded. Let's see. Okay, so in the vehicle, boys, I'm pinned out across the 2 pins across the blower motor. So there's the connector. So of course we should have the 12 volt supply and the differential voltage applied from the blower motor controller as a function of the auto mode or the manual selector. So I'll turn the ignition key on. I'll keep you focused on the mirror. And take my word for it, I am varying the fan speed here, and there's no change as suspected, right? So we've got 12 volts regardless. We've got 12 volt supply, so you know the supply is good, the relay is good. The motor is still in question, of course, but we've got 12 volts on either side. It's not varying, so it doesn't look like the motor, it looks like a control issue, right? By a control issue, I mean either the HVAC module itself or the blower motor module. Let's go to this side of the control module, the blower module, and we'll see what happens. Okay, so back pinned into the blower module there, boys, on the purple and green wire, which is the control. And as you can see, top line there, channel 1. I just can't get this lighting right, no matter what I do here. So you can see we have 9.68 volts on the control, regardless of the blower selector position. So the question is it the HVAC module, or is it the circuit actually feeding this supply back through, and because there's an issue inside here, this circuit is not getting the supply, so it can't pull down the voltage. Don't know, but it is getting 9.6. I still think it is this, and I'll tell you, and again I'll tell you why. So, see these 2 screws? They're kind of important. They kind of hold this blower module, which, as any fool can see, is heavily heat sinked and finned, which means what to any idiot? Is air cooled. It needs to be in the duct with a stream of air going over it for it to keep within its normal operating temperature. Otherwise you'll overheat it and damage it, right? Well, that's exactly what I managed to do. Here's an aftermarket one that I've already bought, boys, because I'm quite sure that this is going to be the issue. Again, the original, and this is the Rock Auto replacement that I bought. It's an aftermarket one. It's not the cheapest one. I don't buy the cheapest one anymore. So you can see they're very, very similar. That's a Mitsubishi product. Yes, it's a Mitsubishi product and a Suzuki. Heavy Industries. This is Chinese garbage, probably, right? But again, not the cheapest one. It was from Rock Auto, as I mentioned. And it was $65 with $10 shipping. $66 American, which is like, with the exchange rate these days, about 4,000 Canadian. I don't know what it was. It was $115 Canadian all in, boys. So, as I said, because I left it at the Airstream, what happened was my evaporator drain line is leaking. The evaporator got bunged up yet again, so I had to clean it with some cleaner. And I was going to do it multiple times, and I made the mistake of getting lazy, and I thought, well, I'll just slot that into the ductwork and I'll set it, that way I can put it in and out in the course of a couple of days while I clean the evaporator and get the swill out of the drain tray so it'll start draining again normally. Yeah, well, as luck would have it, of course I need to take this vehicle to work. What happens? It migrates its way out the duct, falls out. I see it hanging in the footwell one day, and then I could add 1 and 1 together and make 2 that yeah, I had overheated the module by being stupid and not taking the extra 30 seconds to put the 2 screws in. So that's the new module in place with the 2 screws firmly in place, which took me all of 15 seconds. So down to the meter there, boys, and I'll just I'll put the ignition switch on. I'll keep you on the meter. And I think you can hear the blower is actually operating already, right? So again, channel 1 on the top there, boys, is the control, and the bottom is actually the differential voltage. So we've got 12.6 on one side of the blower, and as you can see, near ground on the other, and that's why the blower is in high speed. And I'll just toggle it down. I'll go through the various speeds. I don't think I need to beat this to death. I've already explained this in the past. So that's the minimum blower speed right there. Maximum. So it looks to me, boys, like inside the assembly, the entire assembly is actually thermally protected by a little thermal fuse that goes across those two contacts there, right? And if it was fit for service, we'd have continuity across those two pins. So you can see there's a little heatsink compound actually bonding it. Yeah, so there it actually is right there on the drawing. So I believe that's gone. Thermally tripped to protect me from melting my car down from stupidity. How you living, Leon? Hey, what can you do? That's it, boys. Cheers.